Hello, everyone. I have found today a very funny meme that made me exhale out of my nose excessively over the past few minutes. So let's get on with the meme. The meme is a mathematical meme, so we can solve it. So let's see what we need to solve. Apple plus apple plus apple equals 6. What number added to itself 3 times is 6? 2, right? 2 plus 2 plus 2 is 6. Next one. Apple, which we know is 2, plus orange equals 7. Apple plus orange, 2 plus something equals 7. What could be orange? 5, right? Because 5 plus 2 is 7. So we can say this is 5. And how about the next one? Orange, which we know is 5, times hyperrealistic image of a peach equals 10. What could be multiplied to 5 in order to get 10? 2 again, because 5 times 2 is 10. So this is going to be 2. Now, on to the next part of the question. Peach pineapple plus banana e to the power of banana over pineapple, d pineapple, minus pineapple e to the banana over pineapple d banana equals 0. What would be the general solution for this equation? Well, let's transcribe everything into something that's easier to write on with our mathematical eyes. So peach we know is 2. Let's assign pineapple as x. Let's assign banana as y. E is Euler's number, so just so you know. And then pineapple is banana. And let's transcribe the rest of this. Now we see here is a differential equation of this form. Now, how do we solve this one? Well, we need to identify what it is, really. If you're in a pinch, I recommend the SLEBH identification. First, identify if it's separable. Is separable. Is this separable? I don't think so because there's y over x, so this is not separable. Is this linear? There is a term here that is on but is by itself, but I don't think it you can do some stuff in here, so it's not linear. Exact, you can check try checking if it's exact, but I don't think it's exact or Bernoulli. And we're now stuck with homogeneous. This is actually the hardest one. But you can actually skip identifying the entire thing and just go straight to homogeneous because of one simple identifier. This y over x over here, which is a function of e to the something. When something is a function of y over x or x over y, you already know this is homogeneous. So e to the yx or e to the xy or arctan y over x or arctan x over y, whatever. All those immediately constitute a homogeneous equation. Now, it doesn't necessarily mean that it's homogeneous. It just means that there's a good likelihood that it is homogeneous. So let's verify if this is indeed homogeneous. The degree of 2x is equal to 1. This is the degree, is 1. Here the degree is 1. E to the yx has no degree, so that's just 0. So nothing there. In here, the degree is 1. So that's no problem. And this is indeed homogeneous because all the terms have degree 1. So this is now a homogeneous differential equation. So let's solve it like that. My preferred method, and maybe we differ in method, is I divide both sides by 1 over x to the degree or 1 over y to the degree. How do I know when to use one? Sometimes you just gotta pick one and then hope for the best. But in here, we don't have to hope for the best. Look at here. X is on the denominator. We need X to be on the denominator. So we need this. The degree is 1, so we just multiply both sides by 1 over x. 2x times 1 over x, that's 2. Y times 1 over x is y over x. This remains unchanged. For the dx, since x is on the denominator here, we need to divide both sides by dx, but not really because this is not division. This is setting the derivative to x, something like that. The derivative of x, which is what we're seeing here, is just 1, so we can replace that with 1. And dy over dx is y prime, as we all know. So this is the first part. Next part, x times 1 over x is just 1, so we don't need to write that down. E to the yx, though, we need to write that down. And dy over dx is y prime, 0. Now, the reason why we did this is we can see that everything now is a function of y over x, as we mentioned earlier. So y over x equals v at this point. Let's substitute v in here. Now, to have y prime all on its own, we need y equals xv. This is the more familiar form some of you are familiar with. And y prime should be equal to v plus xv prime. This is due to the product rule. And I think other YouTubers such as the Organic Chemistry Tutor skip directly here, but I prefer doing this. There's some that also do this, so this is not unfounded. So there we go. Now, 2 remains 2. Y over x becomes v e to the v minus e to the v times y prime, which is now v plus xv prime. This is now equal to 0. Now, let's distribute this to v and xv prime. So 2 plus v e to the v minus v times e to the v is v e to the v minus x e to the v prime. And when you look at that, this and that cancel each other out. So we remain 2 minus x e to the v prime. Now this is now separable on the SLEBH. Homogeneous usually wants to go separable, and so is linear, but linear is a different story. Uh, so we're now on the separable part of the homogeneous equation. So this is easy. We just divide both sides by x to separate x from v, and we get this. Integrate both sides with respect, of course, to x. Now, this is easy to ln x. This, well, dx means we have to integrate with respect to x. But v prime dx means that we gain permission from x to integrate in terms of v. So we can integrate in terms of v. This is basically saying dv. So this is just e to the v. And the integral of 0, whatever dx, dy, dz may be, just c. And we're not done here because the previous equation was in terms of y and x, and there's still v here, so we need to convert that back. V is y over x, so we get e to the y over x here, and c on both sides. And there you go. Or if you want the fruits, we can do 2 ln pineapple, let's draw pineapple like this, minus e to the banana, I don't, yeah, over pineapple, like that, equals C. Or if you really want the fruits, this can be the peach. Because the peach is 2, right? So something like that. So there you go. That's your fruit laden answer. I hope you have a sweet day and good luck on your exams. See ya.